x squared plus y squared plus z squared equal to 1500. We want to find x, y, and z. In this problem, x, y, z are integers. Let's find all answers. We can say without lots of generality, suppose that x, y, z are greater than equal to 0. Because if, for example, x is 2, we can consider 2 and negative 2. At the end, we consider positive and negative of that number. Now, for this problem, we consider, for example, a variable. If, first let's consider this. If a is even, and also if a is odd. If a is even, it will be 2k. If a is odd, it will be 2k plus 1. And here, a squared will be 2k squared, which will be 4k squared. We can consider k squared cubed. So a squared will be multiplied of 4. Now, here, for this one, a squared will be 2k plus 1 squared. And now, if you want to consider a plus b squared, use these identities. A squared plus b squared, or let's write like this, a squared plus 2ab plus b squared. So I can say it is 2k squared plus 2 times 2k times 1 plus 1 squared. If you simplify, it will be 4k squared plus 4k plus 1. If we factor from 4, it will be k squared plus k plus 1. You can consider, for example, it is w, it is 4w plus. So we conclude the remainder of a perfect square when divided by 4 is 0 or 1. Now, in the main equation, we have 3 perfect squares. X squared plus y squared plus z squared equal to 1500. We consider the remainder when divided by 4. This 0 equal to, each of them can be 0 or 1, 0 or 1, 0 or 1. The only possible case is that 0, 0, 0. We don't have any other possible case. So, x, y, z should be even. We can say x is 2x1, y is 2y1, z is 2z1. And now let's replace these x and y and z in the main equation. If we replace, then 2x1 squared plus 2y1 squared plus 2z1 squared equal to 1500. And now it will be 4x1 squared plus 4y1 squared plus 4z1 squared equal to 1500. If we divide both sides by 4, then we have x1 squared plus y1 squared plus z1 squared equal to, if we divide by 4, it will be 33725. 375. Now, let's write this here. X1 squared plus y1 squared plus z1 squared equal to 375. Again, we consider the remainder when divided by 4. Each of them can be 0, 1, 0, 1, 0, 1. Some of them should be what? 375. The remainder when divided by 4, you need to only consider 75. The remainder when divided by 4 is 3. So we should take 1, 1, and 1. So x1 squared, y1 squared, and z1 squared should be odd. So we conclude x1, y1, and z1 are, all of them are odd numbers. Now, let's consider odd perfect square. 1 squared, 1, 3 squared, 9, 5 squared, 25, 7 squared, 49, 9 squared, 81, 11 squared, 1, 2, 1, 13 squared, 169, 17 squared, 289, and 19 squared, 361. Last one is this. So let's check each of them. 361, without lots of generality. Suppose we consider different cases, for example, the maximum one. Okay. We can say without lots of generality, suppose. You know what we said, x1, y1, z1 are at least 0. X, Y, Z are at least 0. Here, we can say x1 because they are odd. X1 without lots of generality greater than y1, greater than z1, greater than equal 1. Now, if x1 equal to 19 here, it is 19 squared. For example, the previous one is 17 squared. So we conclude what? 361 plus y1 squared plus z1 squared equal to 375. So 9 plus 5, 14. Y1 squared plus z1 squared equal to 14. Now, how can we create 14? Is it possible 25 and larger number or not possible to use 1, 9? 1, 9 plus 9, 18, not possible. 1 plus 1, not possible. So in this case, if x1 is 70, and 289 plus y1 squared plus z1 squared equal to 375. And if you subtract 289 from both sides, y1 squared plus z1 squared, 15 minus 9, 6, and 7, 6, 16 minus 8 is 8, and here it will be 2 minus 2, okay, 86. Now, if you want to create 86, you can use this number. 81 plus 5, 86, not possible. 49 plus 37 will be 86, not possible. 25 from smaller number, it's not possible. 25 plus 25, not possible. So again, we will see it cannot be 17. So we can't have the maximum one. Cannot be this, cannot be this. Let's start from here. Now we need to only check 13 squared. Why? Because if maximum one is 1 to 1, if all of them also be 1 to 1, it will be 363. Won't reach the 375. So it is the last case we should check if x1 equal to 169, x1 squared or 13. 169 plus y1 squared plus z1 squared equal to 375, and y1 squared plus z1 squared. If you subtract 375 minus 169, will be 15 minus 9, 6. 6 minus 6, 0. And 3 minus 1, 2. 206. So let's see. Can we reach 206? If we use 169, the next one should be 31, 37. Not possible. Let's reject it with another color. 121. 121 plus 121. It is 121 plus 81. It will be 202. It cannot reach this. It will be less than. And 81 plus 81 won't reach this. So again, we've reached contradiction for this part. So we've proved that there is no answer for this problem. Let me write another problem for you. You can solve it as homework. X squared plus y squared plus z squared. You can solve and find answer for this. 10,000. And try to find all answers for these x, y, z are integers and comment your answers below this video. And if you have questions, send message to my WhatsApp number. And please don't forget to subscribe, turn on notification, like the video. Thanks. See you next time. Bye bye.